Hey guys, this is Patrick from STH, and today I'm going to show you how to be a superstar. Specifically, I'm going to show you what the impacts are of using modern CPU accelerators and how that basically gets you more bang for your buck, whether you're either in the cloud or you have on-prem, servers that you're managing. And given that we're pretty close to the end of the year when we're doing this, if you have something like your boss said, we would have given you that raise or would have given you that promotion, but you just need one little tiny little thing, or if you're just looking for something as a, to-do item for next year to show like how you're actually helping an organization, this is definitely a video that you're gonna love because I'm gonna show you how you can get some basically free performance out of your existing hardware. Now, the super quick background on this is the fact that modern processors, well, people have figured out that doing every function in the world on general purpose cores is just not the way to go. In fact, there's some things that are done so often that if you offload those to dedicated accelerators, you get a ton more performance, you use less power, so that makes it a greener solution. And basically, it's way better to offload things than just to keep everything on general purpose cores. That is an industry trend. Everybody is doing it in the industry, and we're going to start to see it a lot more in 2022. Now, recently on STH, we actually looked at some of the M6 instances, and we looked at like the M6G for Graviton 2. Graviton 3 is announced. It's not really out in GA yet, but that actually does have some accelerators in it. We just can't show you that because it's not out yet. But then we also use the M6i, where we use the Ice Lake processors. Now, Intel's third generation Intel Xeon Scalable processors, that's called the Ice Lake generation. And those are important because they actually started really kind of incorporating a little bit more of this acceleration technology into that generation. And so that's why we're actually able to show those. Now, that is what we can get today. In the future, especially in 2022, you're going to see a ton more processors from Intel, from all other vendors, and they're all going to have more acceleration. So this is a trend, and this is something that I really want the STH readers and those of you on YouTube to be aware of and be able to take advantage of. Now, when we did that previous piece, some folks said, well, hey, cool that you had some comparisons, but could you do a little bit more, and could you maybe just kind of deep dive in terms of what it looks like if you don't really use that acceleration and you do use the acceleration on the same chip and same instances? And I said, okay, well, I think I can do that, and I think I can get it out by Christmas. So that's basically what we're doing here. And just so everyone has an idea of kind of what we're doing here, we're going to link to the main site article down below in the description. And we're going to have some other links in terms of in that article about like where else you can find some of like, how do I go do this and kind of get more details into like the actual configurations and all that kind of stuff. There are actually guides on using all this stuff. So it is something that's definitely publicly available. And we're just going to go link to that. Instead, what we're going to do is really kind of focus on what the outputs are. And we'll talk a little bit about like, what we're using here. So that way you can do the research. But again, look for links in the description. So just as a quick note here, we are going to mark this one as sponsored because frankly, Intel is actually paying for the instances that we're using on AWS for this. And then the other thing is just I needed a little bit of help in terms of making sure that I wasn't showing you the wrong thing in terms of acceleration. And so we did rely on some of their experts to kind of help make sure that we're doing the right stuff here. Now, like everything on STH, this is being done completely editorially independently, which means that we're running the benchmarks, writing the article, doing this video, and Intel is not getting to review any of the outputs before it goes online or anything like that. And they don't really get a say in what the outputs are, but they are paying for like the instances. So of course we're gonna have to say that this is sponsored because naturally. All right, now that that's out of the way, let's get to some of the workloads. And specifically, we're gonna look at 3 different workloads. We're gonna look at that WordPress example that I used previously. We're gonna do a little bit of a deep dive into that one. And then what we're gonna do is we're gonna look at the TensorFlow example and show some of the options there in terms of using acceleration for AI inferencing that's already built into chips without having to go to GPUs. And the third one we're gonna look at is just AVX512 because, that is a big one. It's still in a lot of domains that is an important one. And I just wanna kind of show you what the impacts are of that. So those are the 3 workloads we're gonna look at. You can use them today in the M6i instances, and let's get to it. Okay, now the first one we're gonna look at is what I call the WordPress one, but really what this is like a little WordPress site. It's actually based on a Facebook kind of benchmarking thing. They actually did WordPress. I think they had a couple other CMSs that they had involved as well, but we're basically using a framework that kind of Facebook developed, which is OSS Performance, and we're gonna be looking at basically what is the impact of doing crypto offload and crypto acceleration on a instance when you're doing things like you have a Nginx, web server. You also are using MariaDB, and of course, because WordPress is PHP, in this thing, we're actually using PHP FPM because, it's Nginx. So of course you're going to use PHP FPM. And the reason that this is important is because if you actually look at what Intel says in terms of their marketing slides, when they say like, oh, our new chips have like 4x better crypto performance, sure, you can get 4x better crypto performance, but when you look at an entire workload or like, entire application or something like that, you don't necessarily get like a 4x improvement because what they're really kind of focused on is like that little part of like, hey, if we just are doing doing crypto, we get like 4x. But when you get into an entire application, of course, that crypto is only a part of it because you have to go do other things in that application. And so what I really want to do is kind of use this as a kind of more like real world example of like a full application and what this accelerator actually means in a broader stack. And I know that there is somebody out there that's gonna be like, oh, I just completed my AWS cert, and why are you doing SSL on, your instance and all that kind of stuff? And the fact of the matter is that most folks are these days developing all their instances, and they're gonna go start doing encrypted traffic between all the instances. So that is just gonna be a big part of everything. And if you don't do WordPress, well, frankly, WordPress is a giant CMS that's used by just an absolute ton, like a huge portion of the internet. So it's a pretty well-known thing. And it's just kind of something that we can kind of use that a lot of people can just kind of resonate with. In fact, we use WordPress for STH's hosting. So it is something that I definitely have used quite a bit. And that's why we're using it. It's just an example. You can have other things, but I'm just kind of using this as an example. Okay, so the first one that we're doing is we're actually using the crypto offload for basically doing the TLS and doing the encryption out of our WordPress instance, right? And we basically have a WordPress instance where you have Nginx, you have the database on the same instance. And so everything's all in one thing. We're running Siege to actually go run our workload here, or at least generate our traffic. And what we can see here is that our transactions per second are about 18% or so higher with using that crypto offload versus not using that crypto offload. So that may not seem like a huge deal, but just think about that. I mean, that's basically like, I don't know, like 1 out of 6. So you get basically for every 6 instances you have, you could get, one more basically free. And that's pretty darn good. Now, the other one that we have is actually the throughput. And that is basically just kind of measuring it in terms of like actual data transferred. And that's like megabytes per second would be the kind of underlying metric there. And we can see there is that we also get, 15-ish or a little bit more than that percent. But a little bit of the feedback that we got when we did the previous one was like, hey, can you talk a little bit more about like things like tail latencies and stuff like that? And so here is just kind of a look at what the tail latencies were in terms of looking at the latency with the acceleration and without the acceleration. And we're going to start with the, 50th percentile. So like what half of the transactions we're able to do, and then all the way down to the 99th percentile. And again, what you're going to see here is that you're, call it 18, 20% or something like that, usually lower in terms of your latencies. And so, for a lot of folks, maybe that's what they care about, maybe not necessarily transactions per second, but then also like, what are my latency, what are my tail latencies? And so even in that metric, even though you are going from the general purpose CPU cores to some of the offload engines that are on these chips, what you're actually going to find is that you still end up even doing that offload, getting to a lower latency distribution because of it. And let me just reiterate here, this is the exact same AWS EC2 M6i 4x large instance. And the only difference is whether we're taking that acceleration path or not taking that acceleration path. And to go implement this, you can go find a little bit more on the STH main site. But realistically, this is something that maybe would take about 30 minutes or something like that to go implement. So it's not actually very hard to go do. A lot of people don't do it. And yet it's something that, you can say maybe 15, 20% more performance. I mean, that's just awesome, right? That's basically free performance that you can just take advantage of for 30 minutes. So again, when I mentioned earlier that these are the kind of things that like you could do like end of year, or you could put into your performance metrics for next year, this is the exact thing that I'm talking about. I mean, these are like, things that will look like, oh my gosh, you got so much more performance, but it really only took a couple minutes to go do. And that's kind of what we're going for. Easy to make STH folks look like absolute superstars at work. And another thing you're going to want to definitely get into if you want to look like a superstar is, of course, AI acceleration. And this is another one that I think is really important because a lot of folks, when they think about AI acceleration, they immediately say like, oh, I have to offload everything to a GPU. And while GPUs are definitely very good at that, on the other hand, there are a couple things that you need to do with a GPU to get really good performance. The first thing is usually you're going to want to offload and have like, a bigger batch size. But the second thing is you actually need a GPU in the first place. And of course, GPU instances cost more. So if you can just use the CPU that you already have and use the accelerator that's already built into that, you don't necessarily need to go and change your instance size to something like, the GPU instance type. And either way, you're going to have to take advantage of the acceleration, whether that's GPU acceleration or the CPU acceleration. So that work is actually not too different. But on the other hand, this is something that you don't have to go and use that GPU. Now, the other thing is that there are a lot of applications out there that, especially over the next couple of years, are not just going to do 100% AI inferencing, right? Like you just can't do AI inferencing for absolutely everything in a workload. And so what you're actually going to see is that applications, and we're already seeing this today, that applications actually will go and they may have a couple inferencing. Now, there, of course, again, are definitely the ones that are like all inferencing, and that's like a totally different domain topic. What we're talking really here is kind of like, what are those things that where, you're bringing in a little bit of inferencing every once in a while into an application. And that's really the idea behind having this acceleration on chip. And it is something that some of the hyperscalers have actually started to use, because they're like, well, we have all these CPUs, we don't actually need GPUs for everything. This is exactly what they're doing. Okay, now again, what we're gonna do is we're gonna take the exact same M6i 4x large instance, and we're gonna run a couple of different scenarios on it, right? The first scenario that we're gonna run is really gonna focus just on like not using the accelerator, right? So it's kind of like our baseline. And we're not gonna use the accelerator, and we're gonna be using FP32 as our data type. We're then gonna start using that acceleration, still using FP32, so you can just kind of see the offload path versus the non-offload path. And then finally, we're gonna go and turn up, and we're gonna actually go into INT8 and say, hey, what if we use a different data type? Now, the quick background on INT8 is something that is pretty widely used in the industry, but the idea here is basically that by using INT8 versus FP32, you get more efficient computation, and actually your accuracy is not that much different. And so it's like one of those things that you give up, maybe give up a little bit of accuracy, but on the other hand, you end up getting like, you do compute way less expensively. And so that's why a lot of people have actually gone and said, yep, we want to go do INT8. Now, Intel was actually pretty early in terms of Ice Lake supporting INT8. And when we looked at things like Graviton 2, that didn't support INT8. So like, the numbers were not very good. And so that's just something to keep in mind, that not every processor, of course, supports INT8 right now. And so we're just kind of showing, showing this progression using a processor that we can use today to go and show it. So the first thing that we're going to do is we're going to use batch size 16 for inferencing. And really what that is that is a little bit larger of a batch that kind of lets us use a little bit more resources in that instance. And it's not necessarily going to be the lowest latency, but really you do this for something more like a throughput test, which is exactly what we have here. So basically the big difference here is between the first two bars is really just the fact that we are still using FP32, still batch size 16, but on the second bar, what we've actually done is pulled down the Intel AI kit for analytics, and we're using that to go and start doing our acceleration. So again, we're not changing data types here, but we get like a, 35, 40% better performance just by changing that. But that's still using FP32. So the next bar is what happens when we switch over from FP32 to INT8. You can see that we're looking at like way over 4x. I mean, we're darn close to 4.5 times performance versus our baseline case just by, number one, using the acceleration and using that INT8. And so that is like one of those things that if you can go and bring, and you actually have an application that can use that a lot, that is another one that is a huge number that you can go show, and it's pretty easy to go do, actually. Again, link in the description for the STH main site where you can learn a little bit more about how to go get set up with all this stuff. This is, again, not a super hard one to get going, but just want to kind of show you. And that is really the throughput at a batch size of 16, but something that CPUs are actually really well known for and doing a decent job at is doing inferencing at lower batch sizes. So like, well, let's look at like a batch size 1. And the reason that you use batch size 1 is because, well, maybe you just have one thing that you need to do inferencing on, like one call. You just need to go and pop out one result, right? Or something that is a relatively, it's not like a huge batch of stuff. And the important thing here is that a lot of times this is actually something that you see in actual applications, right? Because if I had to go and say like, oh, I need a GPU for inferencing, and if you're not on a GPU instance, right, you're gonna have to like go over the network, hit the GPU, then get the result to return. And that whole thing is actually gonna be a pretty, I guess, relatively slow process versus just keeping everything on the CPU itself. So that's basically why this is actually pretty important. Again, GPUs definitely have their place, but this is why you would do something like this. And here, the impact was actually a lot different than what we saw when we kind of did the larger batch sizes. In fact, when we go and just switch to starting using that AI kit, what we're going to see is that we actually get that like 2 to 2.5-ish speed up versus our base case by just kind of incorporating the AI kit and actually using the accelerators. And then when we go and we say, okay, well, let's go look at INT8. Well, now we're talking like basically like almost like 3.5x to 4x speed up versus our base case by both doing the acceleration and then using that INT8 support. So the interesting thing here is just that when you do batch size 1, it does look a little bit different than when you're at batch size 16, but at batch size 1, a lot of people really care more about the latency. And that is where this solution actually is pretty awesome, because if you look at like basically what the latency impact of going and using that acceleration path versus just doing everything on kind of like the traditional CPU cores and all that kind of stuff, you actually see that by engaging those accelerators, your latency goes down by like 80%. So it's absolutely a huge change or huge delta in terms of your inference latency by using the accelerators that are on chip. That is exactly why we're going to see not just this from Intel, but we're going to see them double down on it in terms of Sapphire Rapids and their next generation of, both GPUs and CPUs. And then we're going to see this in the industry. Like, everybody is going to be doing this AI inference on chip and having these accelerators at some point, because you get just massive gains like this. But of course, this is something that we're using today based on a 2021 chip, not something that is a future generation product. Okay, the last one I wanted to get to was just AVX512, because this is one that, frankly, we didn't do a really good job of really showing in previous generations. We did do some on both NAMD and GROMACS testing, but I just kind of thought that this is a good example of one where, we can actually go look at the impacts of using things like AVX512. Now, we're going to be using here NAMD. Now, NAMD is a super popular application. It's been around for a long time. And it is the kind of thing that, like, if you're doing COVID research or something like that, and you wanted to go and, kind of do some simulations around that, this might be something that you would use for that type of application. But the other thing is just, frankly, in this kind of thing, the NAMD is used a lot in the high performance computing space. And those folks definitely are already all about going and using the built-in accelerators and really kind of maximizing the performance that they get. And so this is kind of, well, the other two are probably really kind of looking at like what people could kind of do in the future, because I don't think the adoption of that is as high. In the NAMD space, this is definitely something that you see huge speed ups by using things like AVX512. And let's go take a look at that. Okay, now the first one we're going to look at is the APOA1, and that's basically a lipid, protein, and water kind of simulation. And it's like 92,000 atoms. I don't know the exact number off the top of my head, but something like 92,000 atoms. And that's basically this thing has been used for a long time. And the usual way that people express these things is like in nanoseconds per day. And here, what we're basically using as our base case is actually not using like no acceleration. This is actually using the AVX2 path. And then what we have is an AVX512 path, which of course you're going to see some performance improvement in. And then you're going to see the AVX512 using the tile approach. Now, tile approach would be kind of like breaking the problem down a little bit more like a GPU would kind of go and do it. So this is something that some people do on CPUs, some people do on GPUs. And I just kind of wanted to kind of show those different approaches. So there's part of it that you get in terms of the optimization by just moving to AVX512 from AVX2, but then the other one is also just kind of the way that you approach things. So this isn't necessarily like completely unoptimized to like highly optimized. It's probably like minimally optimized to highly optimized. And the impact of that is really just kind of, if you're looking at like, rough ballpark percentages, you get about 50% more performance by going from AVX2 to AVX512 without using tile approach. But then when you get to tile approach, then you're talking over 2x. And pretty darn close to 2.5x. Now, one of the things I definitely wanted to show here was the difference between doing things at 8 threads and 16 threads. And I mentioned, of course, that the HPC folks, they're very good at optimizations. And one of the things that they found was actually that by not using hyperthreading in this scenario, you actually get more performance. Now, there are the vast majority of just kind of like enterprise workloads and, just kind of like web scale workloads, hyperthreading tends to actually do pretty well for you. But in these very specific things, you actually see that hyperthreading is not necessarily good. Now, another case I just wanted to show was what, STMV. Now, STMV, this is another kind of pretty common benchmark kind of use case or simulation that folks run. And STMV means the satellite tobacco mosaic virus. And so when I ran that simulation, I also saw that AVX512, just kind of adding that was again about a 50% uplift versus AVX2. But then when we actually went into the tiled approach, we again got about 2.5x. And so you definitely see some good performance improvement overall just by actually using that acceleration and actually doing some of the optimization. But in either case, if you can show anybody like, hey, I can get you 50% more performance or like 2x the performance or something like that, looks darn good for you. And it's something that the HPC folks do every single day. They're really good at optimizing stuff. Now, on the website, there are definitely a lot of folks that do that optimization, but there are a lot of folks that frankly don't do that optimization. And just kind of wanted to show if you do go use these accelerators, what you can get out of it. So overall, I think this is super cool. And basically what I showed you here is 3 things. I showed you what basically happens if you start using things like crypto offload, what happens if you use AI inference offload, and then also what happens if you use things like AVX512 offload for kind of that vector performance. Now, not every application is going to just purely hit one of those specific accelerators, but those actually will make up a lot of times a good portion of workloads and give you just overall better performance if you take advantage of. Also, being able to do things like do inference on the CPU rather than having to go to a GPU or having to use a GPU instance, that can save money as well. And so overall, I just kind of wanted to show you guys, here are some of the things that you can use today. Now, of course, in the future, again, there are going to be a lot more accelerators on chip. This is just kind of the start of it. And so if I were to go and say like, hey, what are the kind of cool things that I could tell you as one of our viewers on YouTube or readers on the STH main site, what could you do to look like a superstar in 2022 or at the very end of 2021 is basically you can go start using these accelerators, because frankly, some of these things don't take a lot of time to go set up. They're relatively easy. Again, check out the STH main site article for more on that. But on the other hand, we also know that this is going to be an industry trend that is going to continue in 2022. And because it's an industry trend, a person that has actually watched this video is going to have a leg up over folks that haven't watched this video, because they're going to be like, hey, I actually know about this and I'm going to go take advantage of it. And if you do take advantage of it, you get a couple benefits. One, you of course get the cost benefits of it, but the other side to it is that when you offload things to accelerators, you're using less compute resources, less power means you need less servers. And so you can also just kind of think of it like, hey, I'm being green. I'm helping the environment by not doing things inefficiently by using just general purpose cores and instead using accelerators. I know that that's going to be a little bit of a stretch for some folks, but if you have acceleration hesitation, well, that might be just the thing that you need to kind of push you over the edge and actually start using it. So overall, I hope you guys enjoyed this video. We're definitely going to have more of this on the STH main site, and we're going to start looking at this more as the new generations of processors come out in 2022. And hey, like always, if you like this video, well, why don't you give it a like, click subscribe, turn on those notifications so you can see whenever we come out with great new videos, especially in 2022. As always, thanks for watching. Have an awesome day.